another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. You know, everyone expresses their creativity in various ways. So, for some people, it's through their writing, like authors like to express their creativity through their books. For other people, it's art. They'll create beautiful art pieces or sometimes very abstract art pieces. The world of art is a very, very weird world. People, find some things to be very nice and others find it to be hideous. It's a really weird world. But regardless, people express their creativity through art. But I would assume for most of you, if you're like me, we tend to express our creativity through our technology, specifically, in like the software that we develop and also the hardware and services that we run in our home labs. Now, in this episode, I kind of wanted to expand on that idea that since, typically us more analytical folks, we're not really seen as creative types, but I'm here to argue that in fact we are fairly creative, especially, how we express ourselves through our software development, with a kind of more of a focus on game development, mainly because it's pretty easy, I think, to make the correlation and, to make the argument that software developers are fairly creative people, even though on the surface they might seem very analytical. So that's coming up in this episode. But before we get into all that, let's start off with our trivia question for the week. So, what is the name for a substitution cipher in which each letter in the plain text is replaced by a letter some fixed number of positions down the alphabet? So what is the name for that substitution cipher? And that is your trivia question for the week. Now, before we get into the cybersecurity tip, one thing that I wanted to kind of bring up quickly is kind of how crazy it is, the popularity of this podcast. Now, by no means is it all that popular, but the thing that is I find interesting about it is the fact that it has continued to grow since the inception of it, and that has been due to absolutely no part of my own, because one thing that I think I've touched on a few of the episodes is I don't do any promotion by myself. Like, sure, the organization, quote unquote, Dark Assassins Inc. posts on their social media accounts, but if you've actually looked at the number of followers they have, it ain't doing anything. But the thing is, the reason why this the podcast is growing is because of you all, because you all are out there spreading the word and kind of getting the word out, subscribing, liking, all that stuff, sharing around. So it's really a grassroots effort, I would say, all thanks to you all. So I definitely appreciate all the work that you guys do out there, and thanks for all of it, and definitely keep it up. Now, with that kind of, I guess, self-promotion / administrative stuff out of the way, let's get into this week's cybersecurity tip. Now, this week's cybersecurity tip sort of builds off last week's in a way. So last week we talked about, how to protect yourself from social engineering attacks. This one specifically is to be mindful of shortened links, or really any links. Specifically the shortened links, because it's not all that uncommon for folks to hide malicious links in shortened links through something like bit.ly or tinyURL. Those are two of the more common URL shorteners out there. So if you're not familiar with what URL shorteners are, there's essentially a tool that allows you to put a very long URL and condense it into a much shorter one, so it's a lot easier to like copy and share around, so you're not, sending this long string of a URL around. The problem with them, though, is you can't easily identify where that link is trying to take you. And as we've kind of discussed on previous episodes, not knowing where you're going or thinking you're going somewhere and actually going somewhere else can have some pretty nasty implications, especially if you're going, like, for instance, on the social engineering one with like phishing attacks, you can at least see the URL, and if you click on it like it's a fake bank website or something, it's not like a direct link to download malware or anything like that, in most cases anyway. But with these URL shorteners, you have absolutely no idea if it's a direct link to download malware or if it's just a link to someone's Facebook post of their dog. You have no idea. So you definitely want to check those links before you just paste and enter them into your web browser. But the same thing goes for just any links that you find out there, because if you've ever dealt with web development before and just HTML, there are these things called hrefs, which are basically the way that you can link, essentially hyperlink text. So you can, put a link and then hyperlink it to either another portion of your website or some other website. So in theory, what you could do is you could have one of these href tags that links to some website, but in the text that is, I guess, incorporated for the href. So essentially, if you're not familiar with how HTML works, you basically have an opening and a closing tag, and then in between that you can put whatever your data is. So for instance, with these href tags, or I guess they're technically A tags, with the href being the link portion, between the A tag you can essentially put what text will be essentially the link. So whenever you click on that text, it'll take you somewhere. So usually you might see something like sign up at the link below, or sign up at this link, and link will be the highlighted and underlined text. Then if you click on link, it'll take you wherever you need to go. That's essentially what we're talking about here. So in theory, rather than putting link there, you could put some URL, but the actual link that it takes you, if you're writing the HTML yourself, you could put a different link, so someone clicking on that thinks they're going somewhere, but actually are going somewhere else. You pull the old switcheroo on them. So definitely want to make sure that you're checking the links before you just blindly go to them. Now, the latter one there is generally fairly easy to detect, because if you kind of hover your mouse over the link itself, usually kind of in, I think it's like the bottom corner of your web browser. I guess it depends on, which particular browser you're using, but it might be the bottom left or bottom right corner or something like that. And you can kind of see the link, like a preview of the link that it's going to take you to before you actually click on it. Or if you want to get super fancy, you could, do like an inspect element on the link and kind of see exactly what it's doing. So that's some ways that you can kind of get around that. But regardless, you definitely want to be checking the links before you click on them, because the last thing you want to do is accidentally click a link and go to either a malicious site, or you go to get a direct link to download malware or something bad like that. So yeah, definitely be sure that you are checking your links. And that is your cybersecurity tip for the week. Now, let's move right on into what nerdy stuff have I been up to this week. So before we get into some of the programming stuff, because there are definitely some updates to be talked about there, I unleashed my inner DOS dude one this week. Now, if you've listened to the podcast for a while, I've brought up my friend DOS dude one a couple of times, and I think it was last year. We did an interview with him. You can find it where we interviewed him and kind of got into talking about all the various crazy, wild things that he gets up to in regards to, fixing computers, specifically Macs mostly. But the reason I bring this up is I didn't actually unleash my inner DOS dude one, because I didn't take a completely destroyed computer and somehow manage to resurrect it through my mastery skills of schematics and things like that. By no means, not even close. But if you recall back a couple weeks ago when I talked about 3D printing a case for my Raspberry Pi, during that process of kind of working, with the case and test fitting stuff, I had taken off the PoE, or Power over Ethernet hat, that I had on the Raspberry Pi. And during that process, one of the connectors, for the Power over Ethernet hat completely broke off, which is obviously not ideal. So I decided to bust out the old soldering iron and solder the connector back to the board. So it's all working and good now. The reason why it took this long is because I didn't have all of the, let's say, equipment that I needed in order to perform this repair. So that's kind of why I didn't bring it up until now. But yeah, it was definitely kind of fun to do. But yeah, definitely nowhere near the skill or ability that DOS Dude has when it comes to fixing components. But at the end of the day, I did still fix something. But specifically, the reason why this is cool, talking about the Power over Ethernet hat, if you're not familiar with what it does, it's essentially a thing that you can kind of put on top of your Raspberry Pi that allows you to essentially power the Raspberry Pi through your Ethernet connection. So this is fairly common to have on like IoT devices or Internet of Things devices, which is super nice and convenient because with literally one cable, you can not only power the device, but also have internet access or connectivity with the device. Now, of course, you have to make sure that the switch or whatever you're plugging the Ethernet cable into has the ability to support Power over Ethernet, because not all switches have that capability. So it is definitely one thing to watch out for. But it is a nice thing that you can do. But the other thing you also have to take into account is Power over Ethernet is generally regulated to fairly low power devices, because you can only deliver so much power through the Ethernet cable. Now, there are different standards for PoE. There's PoE, PoE Plus, and I believe PoE Plus Plus, and each one of those essentially offers a different level of how much power delivery can be provided. So it is another thing you kind of have to check for. You can't be, plugging in like a PoE Plus Plus device into just a regular PoE switch and expect it to work. So it is something that you kind of have to double check before you go ahead and do it. But it is something I find nice, because it's a lot nicer only having one cable going to my Raspberry Pi rather than two, and taking up an extra outlet on my power strip. So it is definitely nice. So that was the hardware soldering that I got into, but I also, of course, got into some software updates. So I have been talking the past couple weeks about making updates to my encryption algorithm implementations. So first, it started creating a brand new implementation in Swift, and then once I got that working, I realized that I added some new features that my C version didn't have, so I decided to make updates to the C version to bring it back into feature parity with the Swift version, which ironically was being based off the C version and then surpassed the C version. But now the C version is back in full feature parity, so it has config file support, so you can manually specify the key directory to search in for your various keys. You can encrypt and decrypt text now. And you also can manually specify a key size rather than not just being relegated to the 4 default options, which is something I don't think I was in. Well, that and the encrypting and decrypting text were like the two things that I weren't 100% sure if I wanted to do or not, but I decided I'm this far in, I might as well go all the way and do it. So that was good to see, getting those implemented. And then I decided that since I was on such a roll, I would update the Java implementation too. So the Java implementation is unique for a couple of reasons. The first of which is that it's the only one out of the 3 that actually has a graphical user interface rather than a command line one. And the other thing that makes it unique is it was the first implementation that I created, and it is not compatible whatsoever with the C and Swift versions. Now, I guess that's not entirely true, because you could take before I implemented the base 64 encoding, they were compatible with one another, assuming you manually entered in your keys or used the ghost mode feature. Otherwise, the key files weren't compatible with one another, because the Java implementation used essentially serializable, or basically a way that Java allows you to write objects to files without having to like convert it to a string and whatnot. It does all that for you. So that's how I was saving the key files, whereas in the C version, they were being saved directly. They were essentially taking the strings and encrypting them and writing them to a file, so they were not compatible with one another. But if you actually had the keys, you could manually enter them and encrypt and decrypt data. But then when the base 64 feature got added, you could encrypt something with the Java version, and assuming you were able to copy the keys down, you could decrypt it in the C and the Swift version, but you couldn't go the other way, because the C and the Swift version had the ability to decrypt data that isn't base 64 encoded, for just to essentially allow for backwards compatibility. So if you encrypted something previously that wasn't done in base 64, you'd still be able to decrypt it. But you couldn't go the other way, because once I added the base 64 support, I decided that everything that gets encrypted from this point on will be encoded in base 64. So the Java version would not be able to decode it. But I decided to make updates to the Java version to essentially allow for this interoperability. Or essentially, in other words, the ability for a keys file from the C or Swift version to work with the Java version, and data encrypted by the C or Swift version to also be able to be decrypted by the Java version. So the other thing that I had to account for as well was I wanted to ensure backwards compatibility with the Java version, because, one thing that's really annoying with software is when you're working with a current version of something, a new update comes out and it just breaks everything. So I did my best to basically ensure that if you had what I called a legacy version of the keys, it would still default to using those. It's also had the backwards compatibility of being able to decrypt data that wasn't base 64 encoded. So those were kind of the big steps that I had to implement. But the other thing that was kind of easy to do with the Java version was I didn't really have to worry about config files, because it's a GUI, or a graphical user interface. It has a file picker, so you can essentially just use that to do things like getting the keys that way. So it was fairly trivial for me to implement that. Now, at this point, you're probably wondering and thinking to yourself why they weren't compatible in the first place, if this is supposedly some like encryption standard. And it's a very good question and a valid point. And the reason for that is if you look at the blog post that I wrote up about it, which the Elite Encryption Algorithm, blog post, basically depicting how the algorithm works, like how key generation works and how encryption and decryption work. It makes no mention, and was kind of the point of what you do before and after the fact. The point of that blog post was basically just to give the implementation instructions of how it's done and kind of the conceptual idea of how it's done. And then the point of the implementation was just showing how you can use those algorithms to create a functional product. There's no standard for how the keys are to be stored or how encrypted and decrypted data is supposed to be handled. It just basically says, given data, how do you encrypt it and how do you decrypt it? Because at the end of the day, encryption and decryption algorithms, they don't care what the data is. They just perform a sequence of steps, in other words, an algorithm, over said data to encrypt or decrypt it. It doesn't really have any kind of concept of, what it actually is. So that's part of the reason. So in essence, the implementations were multiple variations of how you could, in theory, implement the algorithm and, have a functioning program. But then I kind of decided after I, kind of got into this that wouldn't it be cool if they all worked together? So then that's kind of where I went down this rabbit hole saga of updating everything and kind of adding in that interoperability between all of them. Because, like I said, the standard, if you will, quote unquote, for the encryption algorithm only specifies the algorithm to encrypt, decrypt, and generate keys. It doesn't, make any mention on if the data once encrypted should be encoded in base 64 or some other encoding standard, if the keys should be encrypted and how they should be encrypted, or if they should be serialized. It just says how you generate them and then how you encrypt and decrypt data. So the rest was kind of up to me when I got around to implementing it. But then after I kind of got two versions working and being interoperable with one another, I decided I should probably make the third one as well. Now, the one difference with the Java version still, which I don't know if I'm ever going to update, is the ability to generate keys of any size that you want. So currently the Java version still only supports the 256, 512, 1024, and 2048-bit sizes for keys, but even with that, it is able to utilize keys of other varying sizes, like if it was generated from the C or the Swift version. So that is at least one, I guess, caveat. But otherwise, they are all working with one another, which is nice to see. So those were the updates there. And with that, let's move into kind of the main topic for the episode, which is this idea that analytical types, like software developers, are not creative and aren't very creative people. So I guess kind of the point of this is to really just challenge the notion that creativity is exclusive to artistic fields. Because when it comes to, software development, typically a good software developer is kind of stereotypically someone that is very analytical in nature and very good at problem solving. And there's kind of a disconnect between this idea and being a creative person or having a fertile ground for creative expression. But if you really dig into it and dig into some of the things you have to do as a software developer, there's honestly a lot of creativity that goes into all the various analytical skills that are required. So, for instance, creating innovative solutions for software projects like video games. If you're developing things like algorithms or level design or game design or whatever, it takes a fair bit of creativity in order to come up with things like that. So, which is kind of what we're going to get into for the remainder of the episode. So, kind of expanding on this idea of creativity, trying one of the core parts of software development and software engineering that I like to hammer home is this idea that the vast majority of it is problem solving. Like, yeah, sure, you have to code and write code, but in order to write code to solve a problem, you first have to solve said problem and come up with a solution. And that is where a lot of creativity can happen. Because, whether you're, creating some brand new system, you're creating a game or a level for a game, or you're designing some algorithm for whatever you're designing your algorithm for, or procedurally generating content, whether that's for a level or a map or something like that. All these things take a fair bit of creativity in order to actually implement. Like, if you're trying to create algorithms, for instance, like brand new algorithms that aren't, pre-canned, like a sorting or a searching algorithm, for instance, you have to come up with that idea. And that's kind of how you can blend the analytical side with the creative side, like how you can, analytically identify, the steps in the process for how this thing should work, and then create that in essentially a creative solution. So the other thing too, like specifically with game development, implementing and designing various gameplay mechanics, crafting narratives and storylines, and creating worlds, whether that's procedural generation or just static. All of these things require some level of creativity that isn't necessarily in the same vein as your arts or your literature. Now, granted, they're in like game development studios, of course, you have like a separate like graphics design department that is generally regulated for those to generate the various models of the assets that'll be included in the game. But if you're just like a solo developer writing your own, of course, you are the graphics design department, you are the software developer, you are the infrastructure engineer, you are the everything, because you're essentially a one-man show. But even if you're just a small team, you're probably going to be kind of having your hand in a bunch of different piles of dealing with various aspects of it. So when it comes, I guess, hammering home this analytical thinking portion, this idea of having, an analytical thought process is pretty much essential for trying to understand some of the complex problems that you have to solve when it comes to things like designing algorithms or designing solutions for, the software that you're developing or the game you're developing. And it can really contribute to solving these complex problems by having a very analytical mind. So to kind of illustrate this, in software development, one of the key components to solving any kind of complex problem is being able to break it down into manageable parts and kind of optimizing for those each individual minuscule solutions to kind of bring everything together to form one overall solution. Because if you remember back to the very first episode that we did on the podcast, it was basically kind of removing the mystique that software development is kind of this witchcraft, black magic, and it's quite simple once you break it down behind the scenes. And kind of how we went about it was taking granted, they weren't super complex problems for the sake of explanation, but they were more relatively complex problems that you can't, trivially solve with just using the standard built-in data types to languages. And you had to essentially break down the various components into their components, and those components into their components. So, the person example is one of the most common ones used when trying to teach software development, for pretty good reason, because you have this complex idea of what is a person, and and you basically have to break that down into what are the various components that make up a person, and implement that through code. And that's kind of what we're talking about here when we're talking about breaking down more complex problems or complex ideas into more manageable parts, and then kind of optimizing for those. So whether that's developing data structures, or whether that's developing algorithms or game features, all of this kind of requires an analytical type of thinking in order to come up with these creative solutions. So for instance, if you're like developing a game, for instance, one thing you're probably going to have to develop is how are you going to handle things like your player character, your item inventory, what are items, if you have some kind of battling mechanic, how is damage dealt, how is damage represented, all these various ideas that you kind of have to design and implement in order to make a functional product at the end of the day. So, kind of getting into some more specific solutions, algorithms, as we've kind of touched on, is a excellent example of how you can use you need to have an analytical sense in order to create this essentially creative solution. So, and you can kind of, if you want to even abstract this from software development, one of the most common forms of algorithm usage and development that I'm sure any one of you listening has almost certainly used is recipes. So if you've ever cooked anything in your life and followed a recipe, you were following an algorithm. If you've ever created your own recipe, you created an algorithm. Congratulations. Now, of course, if you're, a professional chef or a baker or something, you don't necessarily think of creating your recipe as creating an algorithm, but at the end of the day, a recipe and an algorithm in, the computer programming sense are more or less one and the same. The just implementation is different. One you're using, ones and zeros, and the other one you're using edible ingredients. So because at the end of the day, an algorithm is just a sequence of steps to perform a certain action. So some of the common ones, like Dijkstra's algorithm or the A-star, pathfinding algorithm, are two different algorithms to find the shortest path from one point to another, traversing a graph, right? Other algorithms are, sorting algorithms, searching algorithms. All of these have predefined steps of how they go through given a problem set to, achieve a solution. So for the searching, the Dijkstra's and the A-star pathfinding algorithm, given a starting point and giving an end point where you want to go, it will, find what points you have to go to in order to get, essentially achieve the shortest path. Now, of course, one of them is more optimized than the other one, but at the end of the day, that is both the, the goal of those algorithms. It's just like if you're creating a recipe for something, let's say you're creating a pie recipe, at the end of the day, you're creating a pie, but, depending on what ingredients you use, you could, achieve a different pie, but at the end of the day, they're still a pie, right? So coming up with an algorithm is kind of like coming up with a recipe, because, like I said, a recipe is literally just a sequence of steps to create a product, right? So if we go back to the pie, a recipe to create, say, an apple pie or a blueberry pie or a pumpkin pie. It's just a sequence of steps to, add certain ingredients, bake for a certain amount of time, and then at the end of it, you have an edible pie. Just like when you, go through one of these algorithms, whether it's a searching algorithm or a sorting algorithm or some other custom algorithm, the point is you have a start point of some sort, whether that's like an unsorted list, and then at the end of it, you have the result, or say a sorted list. So algorithms tend to take depending on what you're trying to solve with your algorithm, it can take quite a bit of brain power in order to come up with a creative solution that not only works, but also accounts for all the various edge cases that you might run into. Now, in addition to that, getting kind of back into the game development aspect, kind of defining how you want to implement certain game mechanics, like we talked about. If you have some kind of battle something or other, like how does damage get calculated? What if you tried to defend? What if you're attacking with at a certain angle? Does that have any impact? All these various things can have an impact on how you implement your various game mechanics. And another thing that kind of builds on this is, kind of this idea of balancing your game mechanics and, how you implement, player progression, through the game itself. Because one thing that when it comes to balancing game mechanics that you kind of have to think of, I guess first we should kind of define what that means. So this is, in essence, what this idea of balancing game mechanics means is making sure that one thing is not completely overpowered and essentially breaks the game, if you will. So let's take an example that I like to harken back to, which is Pokemon. So in Pokemon, of course, there's a balancing that has to go on because you have one of them being the type chart, right? Like you have different types that are strong against some types and weak against other types. So for instance, the rock type is weak to the water type and the grass type. And for instance, the fire type, while also weak to the water type, is strong against the grass and the bug type. So just a couple of examples, kind of having that balance. But then of course you can't just, balance the type chart. You also have to make sure that, certain Pokemon aren't completely overpowered. Like psychic types in Gen 1, for instance. The type chart was kind of broken back then, and psychic types were super overpowered. And then, of course, over the generations, they've done a fair job of, balancing the type chart and everything to, once they kind of realized, some of the deficiencies, but also kind of balancing the Pokemon themselves, right? Like making sure that they don't have access to all the super powerful moves that make them super overpowered, or having an attack stat that's like absolutely game breaking, or having moves with, no repercussions. So for instance, like Explosion, which is like the most powerful move in the game, like, yeah, it's the most powerful move in the game, but it also faints you if you use it. Other super powerful moves out there like Hyper Beam or Giga Impact, for instance, yeah, they're super powerful, but you have to recharge after you use them, essentially losing your next turn. There are other moves that cause recoil damage. Other moves that can cause, secondary effects. So there's various ways that you can balance, this gameplay. But at the end of the day, it all required a creative solution on the part of the game developers in order to come up with these ideas. Okay, so how can we make this powerful move more balanced? Or this move that isn't very powerful, how can we make it, still make people want to be able to use it and add it to their move sets, right? Like maybe, yeah, the move doesn't have all that much power, but it has a guarantee to lower the opponent's accuracy or cause some status condition or something like that. So there are a bunch of different ways that you can balance game mechanics, but again, it requires creative solutions in order to come up with that. Another kind of game development aspect is how do you define behavior trees, or how do you define the behavior of your NPCs or non-player characters, or your AI, if you will. So what kind of behavior trees do the AI go down? Like what happens if I hit a wall? Or what happens if the opponent I'm fighting has moves that are super effective against me? Kind of going down this rabbit hole of thinking, of kind of putting yourself in the mindset of that non-player character, if you will, and kind of thinking how you would handle the situation they're in, and kind of developing behavior trees or algorithms in order to handle the various predicaments that they might find themselves in, and be able to handle it accordingly. And then the other thing, kind of with this kind of algorithmic sense for creativity, is procedural generation. Now, we've talked about this before a few months ago when I was really on that hard game development focus, working on my video game, which has kind of laxed over the past few months for various reasons. But one of the things we talked about was procedural generation, or essentially this idea of creating the environments or the levels essentially on the fly, if you will, or creating it algorithmically rather than having a predefined layout for a map. So for instance, if you wanted to create a cave system that was procedurally generated, essentially, like, whenever the player would enter into this cave, once they enter the cave and the scene kind of transitions, you would essentially algorithmically generate a brand new layout that the player has never seen before. And kind of one of the benefits to procedural generation is it essentially adds endless exploration to the game, and endless replayability, because if every time you go into this new area things are always changing or being modified in some way, there's always something new to discover and something new to explore. But trying to define and design these procedural generational algorithms definitely requires some complex problem solving skills, which of course you need to be fairly analytical in order to do that. And another thing that also kind of requires a fair bit of creativity is designing user interfaces. Now, I am horrible at these. My user interfaces are almost always essentially the MVP, or minimum viable product level of functional. Like, yes, they work, and that is about it. But some people can create some pretty creative and beautiful user interfaces, and of course that requires a fair bit of creativity in order to do so. Now, there are certain platforms or libraries and frameworks kind of give you a fairly easy way to make more appealing user interfaces. So, for instance, like Apple with iOS provides a fairly robust way of creating user interfaces, like through Swift UI, and creating fairly simple and fairly aesthetic user interfaces that are fairly user friendly to interact with. But the other component too, like, yeah, you can have the most beautiful user interface in the world, but if the experience of using it is horrible, it's kind of worthless. So that's kind of the other hand of the user interface, or the UI, is kind of the user experience portion, and kind of how does how the game or the software or whatever, how the user actually interacts with it, kind of that immersion aspect if you're talking about video games. Now, the other portion of creativity when it comes to software development is if you were ever tasked with a new project, or you're tasked with kind of designing something new that hasn't been done. You'll have to do, usually it consists of a couple things. Brainstorming and prototyping are kind of the two big ones. So if someone asks you to, define, a new project for something at work, for instance, one thing that they might ask for is a prototype of it working, which of course the prototype doesn't have to be a functional product. It virtually never is, but essentially just kind of demonstrating the use case of how it may work. So maybe you have you throw up a quick design or something to basically show one or two of the use cases that you're trying to implement. Maybe you hard code a lot of this stuff just for the sake of simplicity to show it working, or just coming up with ideas in general. And as far as game development goes, I think Unity has like some kind of like prototyping engine to essentially quickly test and develop like prototypes for games, and essentially kind of this idea of iterative development and testing, and taking the results from play testing in order to kind of encourage future improvement. So one thing that I've noticed, so of course the game that I'm trying to develop is essentially a from scratch version of Pokemon that I'm writing, and pretty much every time I either watch someone play it or play it myself, or even just working with other code or things going on in the world, it kind of gives me ideas for things that I can add to it. That I actually have a list on my phone of notes I'm taking of potential features and ideas that I want to implement, like down the road once I kind of get a lot of the core stuff built. But playing other games can be a great way to kind of get ideas for how to implement things in your game, and also kind of building off of that. Side projects is also a great way to kind of help overcome some of the common roadblocks or challenges that you might find yourself in, because something that can be kind of a roadblock, if you will, is creating, I guess, like the writer's block equivalent of software development, where you kind of get stuck. So going off and working on a side project can be kind of a great way to do that. Or if you're find that you're experiencing burnout on a given project that you're working on, transitioning and shifting your focus to another side project could potentially be beneficial. Because one thing that I've also kind of found is, I don't know if I've necessarily felt burnout working on my video game, but one thing that I have noticed is if I haven't worked on it for a while, and because I've been focusing on some other side project, when I get back to it after working on the side project, I kind of feel reinvigorated and kind of have this new sense of life and drive, and really start putting some code to the fingers to the keyboard, and hammering out some code. That was a horrible analogy, but essentially kind of giving yourself a brain break, if you will, from always focusing on this one thing. Another thing that can be beneficial, there are these things called hackathons, which, if you've never heard of a hackathon before, essentially it's this thing where it's usually like a day or maybe a weekend or something, where you basically are tasked to come up with some creative solution or creative, really just fostering creative development. I know like colleges and high schools generally tend to host these things, and essentially the only kind of constraint you have is like time limits. You have a whole weekend to develop something, like just create something. So kind of forcing you into a creative mindset to rapidly develop something through some kind of whatever you want to be, whatever you want to make. There are also hackathons specifically oriented towards game development. I think I went to one. It was called Jam Tech. I'm not sure if that rings any bells to anyone, like back in high school. And essentially kind of the point was kind of learn. It wasn't necessarily a ton about developing your own game. I mean, a little bit, but it was kind of more focused on like using game development tools and kind of like some hands-on type things. So kind of going to some of those can potentially not only give you a break from whatever you're working on, but potentially give you inspiration for things that you can add in to whatever you're working on. Other challenges that, I and I'm sure some of you have fallen into is this idea of perfectionism. Like you want it to be perfect, and you will accept nothing less. One of the kind of issues with that is y- nothing's ever going to be perfect, right? You're always gonna find bugs and whatnot, but you kind of need the point here is you kind of have to find ways to push yourself past the imperfections because if you're focusing only on what's not working, you're not going to be able to move on to other things. Like for instance, you know with the game I'm developing, the Pokemon game, there are functions of, the battle scene, for instance, the actual battles. There's a lot of stuff that is not implemented. But if I was focused on the perfectionist of, that specific scene, I mean, I would be at it forever and I'd probably get burned out because I'd be working on the same thing constantly and feel like I'm not really making any progress because I'm always, focusing on this one thing. So kind of identifying, kind of stop gaps or goals along the way, kind of this idea that we talked to earlier on of, having this idea of a complex problem and breaking it down into smaller subsects that you can kind of focus on and work on. Maybe if you identify this one large problem and you can break it down into, I don't know, say like 7 different subcategories or subproblems, maybe you hammer out 2 of those, get those working and get a portion of the overall feature working, and then moving on to something else to kind of give yourself a little bit of a break before then returning to that, maybe knock out another 1 or 2 of those small subsects, and then, go moving on into something else, and just kind of identifying ways where you can branch off to other portions of the project or the game that you're working on in order to not get bogged down with this idea of everything has to be perfect, and kind of, being able to branch off and experiment, with other things. Because if you think back, kind of bringing in some an AI analogy, if you will, one thing that people often run into when trying to train artificial intelligence models is overtraining or overfitting models on a training data set in order to achieve perfection. Because the closer you get to an AI model being able to get essentially 100% on the training data, the worse it gets on generalized data. And the reason is because the AI gets so trained on the testing data that it can't generalize. So when it's basically shown something it's never seen before, its ability to generalize from the training data is essentially thrown out the window if you overtrain it to the training or testing data. So that is kind of one thing when it comes to the perfectionist mindset. If you're always focused in and honed in on perfecting this one thing, it's kind of, you miss the forest for the trees type of a deal, where you're so focused on the tree that you kind of miss the entire forest. So, being able to, work on something, yes, and, come up with a solution, but also, if it's not perfect, get it into a workable state, and then it still might not be perfect, but then kind of experiment with other things and, move on to other portions of the code. And another thing that kind of can be implemented from like a game development perspective is this idea of implementing multiple languages and tools into the game, or this can even work for other pieces of software also. Like maybe you have the back end written in one language and the front end written in a different language, or in the case for like programming, maybe you have the core program written in whether it's Java, C++, or C# or some other language, but then you use either a custom or some other off-the-shelf scripting language in order to handle some of the more dynamic or other features you want to integrate into your game. So for instance, going back to Pokemon, for instance, Pokemon games have, at least the older games, have essentially their own custom scripting language to handle things like dialogue and event interactions. So this is essentially how um, some people are actually able to retroactively create custom, essentially mystery gift events into the games without actually modifying any of the source code, because they're essentially able to write these using the scripting language of the game to write a custom script for an event and then inject that into the game. So if you have, that's a pretty creative solution right there. Essentially having your core game code and being able to inject scripts into the game code to have, dynamic events without you actually having to change any of the source code for the game itself, which I think is pretty cool and something I'll probably try to look into implementing in my own game whenever I actually get to that point. So yeah, that was kind of a whirlwind of, we kind of went all over the place. There wasn't necessarily, I tried to at least have some structure to this portion of the podcast, but it kind of devolved into a scatterbrained, rambling word dump of ideas. But I think at the end of the day, the thing we kind of want to focus on is, if you're a developer out there or you're someone that likes to write code and you hear people saying that you're not a very creative person, hopefully this has at least given you some insight that in fact you are fairly creative, because you have to come up, with fairly complex solutions to problems, and in order to do that, you have to have a fairly creative mindset in order to come up with these problems or come up with these solutions to the various problems that you face. So if you're still listening at this point, congratulations, because this has, like I said, has been quite the whirlwind. And like I said, not a whole lot of structure to it. But if you are still listening, I would be interested to hear your thoughts on, what you do for, creating coding projects, or how you used, your analytical mindset to come up with a creative solution to something. So be sure to let me know either in the comments below if you're on YouTube, or you can shoot me an email at contact@darkassassinsinc.com. But before we wrap up for today's episode, let's return to our trivia question, which is, what is the name for a substitution cipher in which each letter of the plaintext is replaced by a letter some fixed number of positions down the alphabet? If you said a Caesar cipher, congratulations, you got this week's trivia question correct. And yeah, so the cool thing about the Caesar cipher is, if you're ever, if you ever want to get into the world of cybersecurity and specifically cryptography, if you're looking for a quick and not necessarily easy, but if you're looking for a fun kind of side project to work on, implement a Caesar cipher. Take a string of text and, write a Caesar cipher to encrypt it, and then, be able to decrypt it. Because that was essentially the first iteration of the encryption algorithm that I wrote, was essentially a glorified Caesar cipher. Except it was a little bit different in the sense that it wasn't a fixed letter down the alphabet. So for instance, not every A went to C and not every C went to H. That's kind of how the Caesar cipher works. But essentially it was every nth letter in the sequence would go a different step of characters further down the sequence. So it was a little bit more variable, but also, like, if you actually knew what it was, you could easily break it. So the security that I initially employed was through obscurity, by not releasing the source code. But then I actually kind of got more into cryptography and developed the algorithm that I ended up settling on. But point being is, if you want to get into cryptography and kind of a beginner, I guess the hello world, if you will, for cryptography, is write a Caesar cipher. Nice little side project for you to do this weekend. So with that, I think that is probably going to be all that I have for you. So if you enjoyed this episode, definitely leave it a rating and review and subscribe to the Dark Assassins podcast already. And like I mentioned earlier in the episode, keep doing what you're doing and sharing this episode around to your friends and family members. And also, if you have any questions about this episode or have any topics or ideas for future episodes, shoot me an email at contact@darkassassinsinc.com, or you can leave a link, or you can not leave a link. The link for the email is in the show notes, but if you're on YouTube, you can leave a comment down below as well. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.